Hello, Trig class. In this video we are continuing to work on the practice test out of section 9.7. And we had done up through 5, so now let's go on from 6. So from 6, it says to find the dot product, and then we need to know the main result for dot product. And the main result for dot product is if you dot two vectors, it's equal to the product of the length of each vector times the cosine of the angle in between. Okay, we're told in this problem that the length of u is 40. We're told in this problem that the length of v is 25 and that the angle is pi over 4. 40 times 25 is 1,000. Cosine of pi over 4 is square root of 2 over 2. And if you divide 2 into 1,000, you get 500. So you get 500 square root of 2. That's the value of the dot product. All right, next one, you're given two vectors and asked to determine if they're orthogonal or parallel or neither. So just recall how you can tell if two vectors are orthogonal. That they're orthogonal if their dot product is 0. So if you dot this u and v, you'd multiply their first component, would be 7 times 7 plus second component times the second component. So it's minus 3 times 3. So you get 49 minus 9, so that's 40. But the point is it's not 0. So they are not orthogonal. All right, now, two vectors are parallel if one is a scalar multiple of the other. So we need to check to see, is it true? Is u some number times v? Okay, so is the vector 7 minus 3 equal to some number times the vector 7, 3. Okay. All right, so that's the same thing as saying is the vector 7 minus 3 equal to, if you multiply the k through, 7k and 3k. The only way two vectors are equal is if the components are equal. So 7 would have to equal 7k, and minus 3 would have to equal 3k when you compare their components. If you put k, if you solve this one for k, then k has to be 1. But if you put a 1 in here, you'll get 1 times 3, and that's not minus 3. So minus 3 is not 3 times 1, because the k had to be 1 to make the first one to work. So these vectors are not parallel. So it's neither. All right, that is the practice part. There was one problem I didn't finish in class for the lecture, so let's go back and do that one. I did not finish the very last problem. All right, here's the last problem. Now in the previous well, on this page, I'd worked out a way to calculate the work. The work in general is the force vector dotted with the distance vector. That's a way to calculate work. Work is force vector dotted with distance vector. If you're in the case where you've got a constant force and you move an object a certain distance. So for this one, you've got a kid holding or pulling the handle of a wagon. So maybe this is the handle. Okay, and then you could break that down into a horizontal and vertical part of the force, but you don't really need to, because in that previously I showed that the work is the force vector dotted with the distance vector. Now the distance is 50 feet, so you're going to go 50 feet to the right, and that vector then would be $50I, because you only go right. And then you'd need the force vector, knowing that the magnitude or the length of this side is 15. Okay, so you could break that vector down into a horizontal component, which is here, and a vertical component, which is here. So this guy, the adjacent side, let's find out how long he is. Cosine of 40 is adjacent divided by hypotenuse. So the adjacent side is hypotenuse times the cosine of 40. And the hypotenuse, the length of the hypotenuse is 15. So the adjacent side is 15 cosine 40. And I could get the opposite side, because the opposite side I could use sine and say that sine of 40 is opposite divided by hypotenuse. But again, the hypotenuse is 15. So the length of the opposite side is 15 sine 40 degrees. Okay, so vector F is the horizontal component and the vertical component. And that means that horizontal one is just multiplied by I. So that would be 15 cosine 40 degrees. And the vertical one is 15 sine the 40 degrees. Okay, so if you dot F and D, you multiply the corresponding components, which would be 15 cosine 40 times 50, plus 15 sine 40 So right now what I'm doing is I'm calculating f dot d that's equal to this calculation. So when you dot the i's, you'll get 15 cosine 40 degrees times 50, and then plus 15 sine 40 degrees times this guy. You don't see a j, but that's because it's 0j. So you'd be multiplying this times 0. So this term's not even there. And you just get 15 times 50, which is 7,500. And times the cosine of 40. And that you could get on a calculator. And if you do get that on a calculator, it turns out to be where's my calculator? Oh, yeah. That turns out to be I don't know. Can't find my calculator. Oh, found one. Okay. Cosine. Oh, that's right. So 40 cosine. Okay. Times. So wait, now 50 times. Yeah, 750. That's right. That turns out to be 574.53. .53. All right, and then that's it for this video. Thank you.